AWS accounts. Okay, cool. So, hi everyone. Welcome to today's session. Last week we were looking at EC2 instances and how do you launch an EC2 instance and some of the configurations regarding that. I hope everyone would have done the previous lab. So if not, please go ahead and look at the previous lecture. So today's session we will start off with AMIs and snapshots and volumes. And we also have some more extra topics to cover. So we will go ahead with this particular diagram that we already spoke about in the previous class. But I'll recap through this just so that we are comfortable when it comes to doing these configurations, right? So when we talk about a snapshot, we spoke about it last week that a volume that you attach to an EC2 instance can be converted into a snapshot. And that snapshot is something which is a point in time copy of whatever data is present in that particular volume at that point of time that you created the snapshot on. And the snapshot can be copied from one region to another region, and it can also be encrypted using a KMS key on copy. If suppose the root volume is not encrypted, which was one of the questions that I asked in the WhatsApp group, if the root volume is not encrypted, you have to create a snapshot of that root volume, probably copy it to the same region or to another region. On copy, you can encrypt it and then mount it as a volume to another EC2 instance. So from the snapshot, you create a volume. So if the snapshot is encrypted, then the underlying volume is also encrypted. And then the snapshot can be converted back into a volume, obviously, and can also be shared across individual AWS accounts, or it can be made public in nature, right? And then over here, we have the process of creating an AMI. So there are two ways to create an AMI. One is from the snapshot. So from the EBS volume, you create an EBS snapshot. And then from the EBS snapshot, you create an AMI, which is an Amazon machine image, which consists of your operating system, consists of all of the data within that operating system at that point of time through the snapshot. And then it consists of certain application servers and packages that you already installed, right? Or that came with the base operating system of this EBS volume. And then from this AMI, you can launch EC2 instances, right? So in this approach, creating a snapshot from the volume and then creating an AMI is a good practice, because in one way, the instance is not stopped or it's not restarted during the AMI creation process. And then in the second manner, where you have the AMI directly created from the instance, which means it's directly created from the underlying EBS volume. In this approach, in fact, a snapshot is created, but then you will have some IO suspension on that EC2 instance. So it may be restarted during the process of creating an AMI. So similarly, on top, when we have snapshots being copied to multiple regions, we can also have AMIs being copied to another region. So when the AMI is copied to another region, it can also be, the underlying volume can also be encrypted and so on. And this AMI can be shared across multiple AWS accounts, or it can be made public. And the AMI is one of the trivial parts, or it's an integral part of a disaster recovery scenario, wherein if suppose the primary region goes down, you can launch multiple EC2 instances from the AMI that you had already copied to another disaster recovery region. So these are some of the configurations that we'll be seeing on the console. But before doing those configurations, we are going to look at one specific configuration that we didn't see the last week, which is called as EC2 instance with bash script capability. So let's take a close look at this. So you have an AWS cloud within which you have a region, which is US East 1 that we are working with. And then you have an availability zone, which is US East 1A, within which you have a public subnet that is mapped to that availability zone, within which you have an instance of type T2 micro. So there is one configuration that we didn't study the last week when it came to the instance configuration page, which was the third page. And in that page, when you scroll down onto advanced details or advanced configuration, you have something called as user data. And we didn't see that particularly. So what this user data allows us to do is, it allows us to specify some scripts over there, or a set of commands. It can be AWS CLI commands, it can be bash script commands. And these commands are run at the start of that EC2 instance. So you don't have to actually SSH into that EC2 instance like we did the last week and install these commands or run these commands. We can specify these commands in an order that it would probably work on the user data section of the advanced configuration. So when I do this on the console, you will be able to see as to where I put this specific configuration at. And we can go ahead and put this configuration for it to be run at the start of when an EC2 instance starts. So when this T2 micro instance goes from the pending state to the running state, it takes some time to run these commands that you have put at the start of the creation of the EC2 instance. And once these commands are successful, On this T2 micro instance, it has a public IP and a private IP, right? So on the public IP of this EC2 instance, we should be able to view hello world on the browser because we are installing a lightweight web server called HTTPD. So now let me walk you through each and every one of these individual commands and what is its significance. So this is the bash interpreter. This is the way that you call the bash interpreter. This is how you start writing shell scripts. And then the sudo su is the command that you use to elevate your privileges to super user, where SNU stands for super user. Then you're updating the operating system using the command called as yum update -y. -y or -y is just to give a confirmation that you are okay with that command. And then you are installing the lightweight web server called HTTPD. So you write yum install HTTPD-y. And then you start the lightweight web server called as service HTTPD start. And then you keep it running through restarts of this T2 micro virtual machine. So for that, we write the command check config HTTPD on. What this does is, each and every time you restart or you stop and start your virtual machine, it automatically runs this lightweight web server as a startup process. So similar to your Windows, right? Whenever you are opening your Windows operating system or your Linux operating system or your Mac OS or your MacBook, any operating system that you launch, you will have some startup processes that automatically start running when you launch your operating system or when you boot into your operating system, right? So this is one such configuration. So check config HTTPD on states that even through restarts or stops and starts of your virtual machine, we are going to keep the lightweight web server on running. And then we are moving into the HTML directory using the change directory command. And then we are echoing out hello world to a file called index.html that is going to reside within this HTML folder. And then when we go to the public IP of this EC2 instance, we should be able to see hello world on our browser. So let's do this configuration first. And then let's go ahead and learn about AMIs and snapshots that we studied in this particular section. Okay. So I'm right now logged into my EC2 console, into my AWS account. So I'm going to launch an EC2 instance, and then I'm going to walk you through all of those processes. And we are going to create an AMI, and we are going to wait until that AMI is available, just so that we can reuse that AMI for our future labs with load balancers and so on. Okay. So I'm going to go ahead and launch an EC2 instance and do the bash script lab first. So click on launch EC2 instance. I'm going to choose the Amazon Linux AMI, which is my favorite AMI till date. And then I'm going to go with the T2 micro capability. You guys should be pretty familiar doing this process again and again. And when I'm going to the configure instance details, I'm going to leave all of these settings as default. And then I'm going to scroll down until the user data or advanced details sections. And I'm going to input that bash script over here. So let me zoom over here. Let me type in that bash script that I mentioned in that particular lucid chart diagram. Okay, so always remember, if suppose there is any indentation mistake or you have not left any space between one of these commands and so on, this bash script will not work. So I have ensured that, I have done this multiple times previously so that it works perfectly. Okay. So once we have inputted this bash script is going to run, or this user data section is going to run once the EC2 instance is started, right? And once it's going from the pending state to the running state of its life cycle, right? All the other settings we should have been familiar about from the last week, including the network, the subnet, and the auto assign IP address setting. We also spoke about IAM roles and the shutdown behavior in the last week. And one thing regarding stop and hibernate feature is that you have to enable this only when you create the instance, if you want to put that instance in hibernate status. But if you don't enable this while you create the EC2 instance, then you will not be able to put your instance into hibernate after you have created your EC2 instance, right? So that is one thing to note. So this configuration should be enabled if you want to have that feature called as hibernation while you create the EC2 instance, not after you have created it, right? So we are going to later learn about placement groups. I have a wonderful slide deck for that. So it's going to be amazing. And let's go ahead and go to add storage. So I'm going to leave the default 8 gig storage of general purpose SSD volume, and the delete on termination flag, I'm going to disable it. Right. So next we have tags. So I'm just going to give this a name. I'm just going to call this as my web server. But when you're working in an organization, always remember to give meaningful names for your tags and at least 3 to 4 tags for each business unit that you're working for and so on. And under the configure security group, I'm going to create a new security group called as my web server SG. So this is my stateful firewall, my web server SG. Yeah. And over here, I'm going to put port SSH, which is port traffic 22 to only my IP address, which is best practice. But even though if our bash script doesn't work, then probably I will need to SSH into this EC2 instance. But I'm pretty sure my bash script will work. So I don't actually need to have SSH for this particular lab, but I'm still going to have it in case I want to SSH into this EC2 instance and show you guys something else. Right? I'm going to go ahead and go to review and launch. And then I'm going to go ahead and click on launch. So I'm going to choose my key pair, which is my private key and public key. I have already created this in the previous lab. I'm going to go ahead and click on launch. So each and every one of you in this Zoom meeting should also have your own keypads that you created last week. So I'm just going to wait until my EC2 instance comes up. But in the meantime, I'm going to just show you some of the properties of this EC2 instance. So you can see that it has got a public IP and then it has got a private IP from that subnet that it's sitting in. So I'm very much looking forward to the VPC lab that you guys will be doing. So there, all of these concepts will be much more clearer. So other than this, let's look at the volume that was attached. Since today's class is also about volumes, let's look at the volume that is attached to this EC2 instance. So you can see that my web server is that volume of 8 gigs of general purpose SSD that is attached to this EC2 instance, and the status in use state, and it's attached to this particular EC2 instance. So now let's go ahead and do one thing. If our bash script has perfectly run and the instance is in the running state right now and the status checks are initializing, let's copy this public IP and let's paste it on the browser. So I mentioned that once the bash script has run, the public IP should automatically display hello world for us, right? So let's just go ahead and enter. So now it's keeping on resolving, but it's not able to completely resolve. What could be the problem regarding this? So always remember, when it comes to troubleshooting, I specifically made a mistake so that you guys will understand this. When it comes to troubleshooting, always ensure that whatever port you're trying to access on that particular EC2 instance is opened in the security group. So which port did we open on the security group? We've opened up port 22 on the security group. We didn't open up port HTTP on that security group. So let's go back to that security groups of this particular web server. So it's called as my web server SG over here. You can get this from the description properties or the metadata of that EC2 instance. So here you can see that we have under the inbound rules, we have only port number SSH, which is port 22 that is open up to the IP address, which is my IP address. But then I'm trying to access it through the browser, which is port 80. And there is no traffic of port 80 being opened up in the security group. So always remember, by default in the security group, every traffic is denied and the ones that you open are allowed. So I'm just going to go ahead and edit the inbound rules, and I'm going to add a new rule for HTTP traffic. And I'm going to also open this to anywhere, which means anyone in the entire world who knows this particular IP address can hit this IP address and get access on port HTTP to this virtual machine. So I'm just going to go ahead and click on save. And now let me go ahead and see. Let me just refresh this guy. So it's still not resolving. Let's wait. Okay, probably our bash script has been running still. So its statistics are still in the initializing status. So let me just copy back this IP address again and let's go ahead and refresh. So it's still not connecting. Probably let me open it in a new tab, paste. So it's still not running. So we'll just wait and see. We'll wait for some more time. We'll give it some more time for the bash script to run, or else we can directly go ahead and SSH and let's troubleshoot and see what went wrong. But let's just wait for some more time. Okay. Okay, so 2 out of 2 checks have passed for the my web server. Let's just refresh this guy. Okay, so it's still not working. Okay, so let me go ahead and SSH into this EC2 instance. So the public IP. So these are the steps of troubleshooting, guys. So if at all I made a mistake, let's troubleshoot and see. So I'm copying the public IP. I'm opening up my terminal. So I'm just maximizing this. So I'm going to go into the downloads directory. Okay, so I have written the SSH command to go into the EC2 instance. So you should be familiar about doing this command. So now let's troubleshoot and let's just check whether the HTTPD service is running or not. So service, let's go to sudo su first. Let's elevate our privileges to super user. Okay, so let's check service HTTPD status. So this guy is running. It's perfect. Okay, so now let's look at whether we have that file within the var.www/html directory. So we do have the index.html over here. So that means everything is working fine. The HTTPD service is running and the index.html is there. So let's go back to the browser and let's try to resolve this again. Brilliant. Okay, so our bash script was fine. It's just that we had to wait for some more time. But anyways, I showed you the troubleshooting steps regarding this. So we have hello world displayed on the browser on port 80. We opened up the security group for port 80 and automatically we were able to see this. And we also did some troubleshooting by going into the EC2 instance. Okay, that's cool. So now since we have done this lab, let's go ahead and create a snapshot from this volume. And then let's look at some of the properties of that snapshot. So I'm just going to go scroll down into volumes. And you can see that we have our my web server instance over here, that particular volume that is attached to that instance. Let's click on actions. Let's click on create snapshot. And all we need to do is give a name. So I'm just going to give it as my web server snapshot. And I'm going to click on create snapshot. Okay, so once the snapshot is being created in the background, do you see yourself logged out of this EC2 instance? You're not, right? So this is one of the best practices in order to create an AMI is that you create a snapshot out of that volume, right? And then you go ahead and create an AMI out of the snapshot, right? So let's go to snapshots and let's see. So one snapshot is in the pending status. Let's wait until the snapshot is created. But in the meantime, I'll walk you through the properties of this snapshot. So you can see over here, the snapshot has a KMS key ID that is associated with it, which means it can be encrypted. But right now, this snapshot is not encrypted. And then you can see under the permissions tab, you can add an AWS account number over here to give that account permission to our snapshot, right? Or you can go ahead and make your snapshot public, which means anyone will be able to search for your snapshot, right? So either way is possible. Other than this, you can also click on actions on top. And then you will be able to create a volume, which is the reverse way. So from the snapshot, from the volume, you created a snapshot, which is in the pending status right now. And from this snapshot, you can create a volume again. You can create an image from the snapshot, which is the next step that we will be doing. And then you can also modify the permissions, which we saw right below over here. And then finally, once the snapshot is in the completed status, you will be able to copy the snapshot to another region. So let's see if it comes to the completed status. It has come to the completed status. It's pretty fast. AWS is really good. So now let's just do the copy to another region. So you can see once you copy the snapshot, you can copy it to the same region, or you can copy it to any other region that you want, right? And at the same time, while you copy the snapshot, you can go ahead and encrypt the snapshot. So you can use the default master key for AWS EBS, or if you have any other key that you created in KMS that you would like to use to encrypt this snapshot, you can do that. And this encrypted snapshot, when created a volume from, right? From this encrypted snapshot will also be encrypted, and that volume that is attached to that EC2 instance, the underlying data will also be encrypted. So that's how you encrypt a root volume, or you encrypt any other volume from a snapshot that is not encrypted, by just copying it to another region or to the same region and encrypting it, right? So we are not going to copy right now. So just to show you that it's there is this particular configuration regarding encryption of snapshot on copy. Okay. So one more thing that we are going to do right now is from this snapshot we are going to create the AMI. So I'm going to create the image from this snapshot by clicking on actions and clicking on create image. So we have to give the name. So I'm going to give the name for this AMI. So I've called this as my web server AMI. Probably the same I'll give it for the description, right? And you can see the architecture is, 86 64-bit or ARM or i386. The virtualization type is hardware assisted virtualization, but you can also have this AMI as a para virtualized AMI. The root device name is over here because we have only one volume associated with this guy, which is the root volume of 8 gigs. But you can also choose to modify this volume size right now while creating the AMI. Okay. You can also add any additional volumes that you would like to. But always remember the root volume should be of volume type, general purpose, or provision diops, or magnetic, right? So we are just going to leave these settings the same. We have just only inputted our name and the description. Let's go ahead and click on create. So the create image request has been received. So where do we see that? When you scroll up to images over here under AMIs, you should be able to see that one AMI would have been created over here. You can see that it's immediately in the available status. Okay, got the idea? So now with this AMI, what are the things that we can do? So we can go ahead and launch an EC2 instance out of this AMI, or we can go ahead and go for a spot request, or we can deregister this AMI, which is going to delete this AMI. We can register a new AMI. We can also copy this AMI to another region. So when you copy this AMI, you can encrypt the underlying EBS snapshots. That is also possible. So when you copy your snapshot, you can go ahead and encrypt that snapshot that you're copying. But when you copy the AMI, which is being, the underlying snapshot that is being used to create that AMI can also be encrypted. So right now we didn't encrypt that snapshot. So we are also not going to encrypt this particular underlying snapshot. But you can see we can choose the destination region to be any other region, or even the same region, which is Northern Virginia also, right? So even copying AMIs are possible. So we're going to click on cancel. So always remember the encryption process happens when you copy from one region to another region, or even to the same region, but only when you copy. You can encrypt an unencrypted snapshot or an unencrypted AMI. And similarly for snapshots, when you can share it with other accounts or make it public. Similarly for that, even with AMIs, you can share the AMI with another AWS account, or you can make it public in nature, right? So either way is fine. So you have all of these properties. Now let's do one thing. So since this particular AMI has our HTTPD server already installed with our index.html already within that HTML directory, within that EC2 instance, or within this AMI itself, let's go ahead and launch this AMI into an EC2 instance, and let's see whether we are able to, go through, not necessarily to log into that EC2 instance, but then directly take the public IP and paste it on the browser, and immediately we get the hello world message, right? So this hello world message was from the previous EC2 instance that we wrote the bash script from, but this AMI already has all of those things pre-installed. Let's launch an EC2 instance with this AMI. So directly takes us to the second page, because in the first page we have been choosing our own AMI, right? But just let me show you that also. So over here under my AMIs is where your AMI will be listed. So you are going to click on select, and you can see we are going to go with the T2 micro capacity over here again, and the configure instance details, everything I'm going to leave the same. I don't have to input the bash script and all over here again, because I already have it within the AMI. So that is how important it is to create your own customized AMIs for your organization, to already have some tools or programs or packages pre-installed and so on. So let's go ahead and add storage. By default, it takes the AMI's root device volume mapping, which is that 8 gigs. I'm going to click on add tags. So I'm going to call this as my web server from AMI. Just for us to identify that this is from the AMI that we created, and configure security groups. Again, over here, I'm going to go ahead and choose the previous security group itself that I created, which was called as my web server SG, right? This is the one that we created recently, which already has port 80 open to the outside world and port 22 to my IP address. And click on review and launch. Click on launch. I'm going to choose the same key pair. Go ahead and click on I acknowledge and click on launch. Now when this EC2 instance comes up, right? So we have this guy where we wrote the bash script. My web server was where we wrote the bash script, and we troubleshooted. We logged into it. We checked whether things were fine, and then we saw it on the browser, right? So this is the public IP of that my web server. But now this particular EC2 instance, we have created it from the AMI. So once this guy comes to the running status, it has come to the running status. We don't even have to wait for anything to run. Immediately when we take the public IP and we paste it on the browser, we should see hello world. Oops, it's not there. Probably we'll have to wait for a little bit of time. Let's just wait for some more time then. Okay. Let's wait for all the processes. Let's just refresh and see once more. Yes, awesome. So we already have hello world over here. That's brilliant, because this guy is from the bash script that we inputted, and this guy is directly from the AMI that we created out of the snapshot of this guy. Right? So I'll repeat it again. So we went ahead and created a snapshot from this EC2 instance, created an AMI from that snapshot, and then we went ahead and launched an EC2 instance from that AMI, which already has everything that is there within this guy. Right? So that's how you create AMIs. You create them from the snapshot. But one more way that you can create the AMI from is directly clicking on this particular EC2 instance that we had initially, and clicking on actions, clicking on image, and then clicking on create image. So this is directly from the volume, which means that your EC2 instance would probably have some IO suspension, would probably be restarted. So let's give it an image name. So I'm calling it as my web server AMI from instance, and I'm clicking on create image. But they have given this option called as no reboot. So it does not shut down the system while creating this image. So if you leave this checked, it means your EC2 instance will not reboot. If you don't leave it checked, which means your EC2 instance will be rebooted. Okay. So this is also one more way to create an AMI. I'm not going to create it from the instance, but just telling you that there are two ways to do it. Right. So one is from the snapshot. One is from the snapshot that you go ahead and create the AMI. So when you go to AMIs over here, you can see that, right? So now keeping all of these concepts in mind, right, that we created an EC2 instance using a bash script. You learned how to do the bash script, and then you created a snapshot out of it, and then you saw all the properties of a snapshot, and then you created an image out of it, and then you saw all the properties of the image, and then you launched an EC2 instance from that customized AMI. So all of these configurations are there, but then these are all manual stuffs that you do, right? So these are all manual operations. So you do the snapshots manually. But then how do you do the automated fashion of snapshots? We will learn that also. So let's go to Lifecycle Manager, which is called as Data Lifecycle Manager, wherein you can schedule and maintain the creation of EBS snapshots for your EC2 instances based on tags. Okay, so let's create a snapshot lifecycle policy. This could also be out of the scope of the Solutions Architect Associate exam. I'm not sure whether they have included it in the new syllabus. I may have to check on it once, but then it's good to know that there is one configuration like this also. So just know this from the high level overview. I'll walk you through each and every setting. So we will create the snapshot lifecycle policy, and you can see over here we have to give it a name. And now you can see over here, we can directly choose whether we want to create the snapshot from the volume or from the instance. Let's do it from the volume, or we can also do it from the instance. So let's click on instance, and let's click on the tag that we are going to associate. So the name tag is going to be my web server. So yeah. So for this particular tag, all the EC2 instances that are associated with this particular tag, for these EC2 instances, I'm creating a snapshot lifecycle policy, right? I'm going to go ahead and give the schedule name as default schedule itself. I'm going to run it every 1 hour. So you can see you have the granularity of running it every 1 hour to 24 hours, right? Sorry. So I'm going to run it every 1 hour, and I'm going to start this snapshot creation policy at midnight UTC, right? And I'm going to retain 6 snapshot, which means I'll have the last 6 hours of data that I want to restore back into my EC2 instance, if at all there is any disaster and so on in that particular availability zone. So I will have my snapshots with me. So I'm going to run this policy every 1 hour to create a snapshot of EC2 instances that are tagged with this particular tag, which is called as name and my web server. Let me scroll more down. So you can see that you can also copy some of the tags that you already have. So this is regarding the tagging, or you want to, add any additional tags, that is also possible. And then there is something called as fast snapshot restore, where you will have additional charges that are being applied. It's again out of the scope, which we are not going to discuss. And then you can also, while you create these snapshots for disaster recovery purposes, you can also go ahead and copy these snapshots to a target region for DR scenarios, right? So while these snapshots are being created, it will also be copied to another region. So I can choose to go with the Mumbai region where I want these snapshots to be copied. So the snapshot retention is going to be 5 days after creating. And I'm not going to encrypt these snapshots, but you also have that facility of encrypting the snapshots, right? And you want to copy the tags from the source volume? Yes, I want to do that. And the best thing about this is you can add any other additional regions that you want to also. So I'm going to add the Paris region too, and I'm going to go with 5 days, and I'm not going to encrypt. So you can see that while you do the creation of these snapshots on a scheduled basis, like every hour and so on, you can also copy these snapshots to multiple other regions like Mumbai or Paris and so on. So this is amazing, guys. And then do you want to exclude the snapshot of the root volume? I don't want to. Let the snapshots of the root volume also be there. But then now comes the catch as to why is he asking you for an IAM role? You are the person who is giving this configuration. You are the person who is giving this configuration on a schedule to go ahead and create the snapshots from the EC2 instances. But then who is doing it on your behalf? EC2 is doing it on your behalf. So that means it needs some kind of authorization from your side for it to do it on your behalf. So for that, we need an IAM role. So similar to how we studied about S3 cross-region replication, where we had to specify an IAM role for S3 to do the copying on our behalf. So all that we did was only upload our objects to the source S3 bucket in one region, and it was automatically replicated to another region. Similarly, over here, we are creating the snapshots in one region, and then we are also telling a data lifecycle manager or EC2 to go ahead and copy that snapshot to another region, and also create those snapshots on a regular schedule, like 1 hour or 2 hours and so on for DR scenarios, right? So for that, we need to give it some kind of authorization. So therefore, an IAM role comes into play. So we will leave it as the default role. And over here, it gives you a policy summary. So maximum of 6 snapshots will be retained. The oldest snapshot will be only 6 hours old because we chose to retain only 6 snapshots, and we are creating snapshots every 1 hour. Okay. And the cross-region snapshot is enabled for US East 1 and also for the Paris region. Okay. So let's go ahead and click on enable policy and click on create policy. So now it has gone to the success status. So the policy has been created. So therefore, within 1 hour or within 1.5 hours, or by the time that we finish this particular class, we should be able to see some snapshots that have been created for that EC2 instance. I'm going to keep it running so that we'll be able to see that. And you can see even some of the other details over here regarding the cross-region copy, which has been enabled for the Mumbai region as well as for the EUS3, which is the Paris region, right? So I'm going to leave these policies as it is. I'm not going to delete anything. Okay. So now we are going to take at least 5 to 10 minutes break, and I want you to go ahead and create your own snapshots from that same EC2 instance. I don't want you guys spawning new EC2 instances. I want you to create the snapshot from this my web server EC2 instance. I want you guys to give it your own name and then walk through the settings of creating snapshots and AMIs. And then I want you to create an AMI from that snapshot, and then probably go ahead and look at whatever configuration I have done on the lifecycle manager. Not probably create your own policies over here, but just look at it once. And then we are going to go to the next topic where we will be looking at elastic IPs, network interfaces, and something called as placement groups, which is very interesting, right? So I'm going to stop the recording for right now. I'm going to give you guys 5 to 10 minutes to create your own snapshots from this particular EC2 instance, which is called as my web server.